So welcome back. So we are going to discuss a very classic problem that is directly based on the slow and fast pointer intuition. Okay. So question is that you are given a linked list and you have to find and return its middle node. Okay. And there may be case when there are two middles. So return the second one. Okay. So let me take one example. Suppose you are having one middle node with 5 nodes. Okay. This is 1 2 3 4 5, right? So the midpoint is that this one, this is the middle node, midpoint or middle node. So you have to return 3 in this case. Okay, if suppose your example is having 4 element, okay, so which one you have to return? So there are two middles in this, so you have to return the second middle, so you have to return 3 again. Okay, so this is the case. So the linked list should have at least one node to find out the middle, and linked lists contain the unique elements. Okay, because we are returning the value. Suppose one more 3 is here, so we are not sure like which 3 I am returning. Okay, so that's why we are keeping the unique element in that. So the most intuitive approach, a naive approach to solve this kind of problem is to traverse the linked list, right? So I am going to traverse this linked list one loop, like, and maintaining one counter. So when I'm reading the next, I'm incrementing the count. So I'll do this until I reach the last. So for this count will be coming right 5, right? Then again I'm going to run a loop on a for loop, like, okay, and where I equal to 0, I is less than 5, okay, and I plus plus. In that case I have to return I less than 5 by 2 because I have to find out the middle one, right? Not I equal to 5. So you are going to reach somewhere here, and then we're returning this. Okay, so this is going to work. The only problem is that you are going to use 2 loops, right? And of course the space, I mean the time complexity is order of n, which is linear time, but still this can be improved. So we are trying to find out the mid of the point in one go, in one loop itself. So for this we are going to use fast and slow pointer approach. So what does it mean here? How this is going to apply here? One fast pointer is there, one slow pointer is there. Okay, so fast is moving with a double speed of slow pointer. Slow is moving one by one step at any point of time, and this is moving with a double speed. Okay, so suppose there are 5 elements in this. So fast pointer, when reach at end, the middle will be somewhere in the middle, the slow pointer. Okay, so slow will be here and fast will be here. So this is the concept of baseline that we are going to utilize. If a fast pointer moving with the double speed of the slow pointer, so when fast pointer is going to reach at the end of the array or linked list, at that moment the slow pointer is somewhere pointing to the middle element. Okay, so we have to take care of that. Okay, so again I'm how to achieve this. So for this, again we are going to use the fast and slow pointer technique, and we are going to move a slow pointer one node at a time, while we'll move the fast pointer 2 nodes at a time. Okay, so hope this is clear. So let me implement this now. So I open my IDE and I'm going to remove this for now, and this class again I'm going to use till linked list we are going to be using. So I'm going to use this as a base class structure for the linked list. Okay, so I'm going to create one class, that is find middle. Okay, and in this I'm going to create one static method, public static, and this is going to return the node. Okay, so list node will be return type find middle, and I'm going to pass the list node head. Okay, all right, so first I have to check head should not be null and it should have at least one node. So let me check that. If head is equal to null, then nothing I have to do, so I'm simply return null. Okay, and then I'm going to create two variables, slow and fast pointer. So list node slow, that is also going to point the head, and then again list node fast, that is also going to point head. Correct? So what you have to do, while we have to keep on moving with a fast pointer, and you have to wait until fast is reaching to the end of this given node. Okay, so while fast pointer is not equal to null and its next also should not be null. Okay, because in case of when two middles will be there, that case might come. Okay, is also not equal to null. Then I'm going to do something. So what I'm going to do, I'm going to move slow equal to slow dot next and fast equal to fast dot next, right? 2 times I have to move, double of the speed. So once this loop is over, so whatever the position of the slow pointer, that is middle. Okay, I'm simply going to return slow. Hope this is okay, right? So let me create one main method to test it. So in this I'm going to copy this example so that I can create one node, because I required this. Okay, let me create by ourselves. So list node head, that is equal to new list node, right? And I'm going to start with 1. I'm going to copy this. So what I'm going to do, head dot next. Now this is not required, I already got the head, right? Head dot next, that is also one node, so I'm going to give it 2. In the same way, let me copy some nodes. Okay, I'm going to do 3, 4, 5, 6, and this will be 2. This will be next dot next, remember, next dot next, and this will be dot next, 2 next, and 3 next, right? And this will be having 4 next now, dot next. Okay, in the same way I'll be having 5 next here. Okay, so I have 6 elements. Now I'm going to find out the middle of it. So list node mid list node is equal to find middle. I'm going to pass the head. Okay, I'm going to now system dot out dot println, and I'm going to pass the mid in that. Okay, so this is the 6 nodes, so probably I'm going to get, in this case, 4, and there will be 2 middle. Okay, 3 and 4. So ideally we are going to consider 4, second part, right? So let me run that now. Some error came, cannot fill next because next is null. Okay, let me check that. So 2, 3, 4, 5. Okay, 1 next is extra. Correct. Now let me run that. So this is not printing two pointers list node. Let me mid dot value I think I have to print, not the node exact. So let me run that again. Yeah, 4. If I comment it out, let's see that case also. In this case now 3 should be the answer, because it's a odd number. Okay, so in odd number there will be only one middle element, 3. So this is a small program for this. So hope you understood the pattern and you understood this program also. Okay, so see you in the next one.